All right, so here is a fraction that we want to do partial fraction decomposition on. Now, I haven't said anything about what to do if it's a cubic factor, right? But remember this from days long gone, that if you have the difference of two cubes, this will factor as a minus b times a squared plus ab plus b squared. So we're going to use that to factor this denominator. So the a and the b here are going to be x and 2 because that's what's being cubed, x to the third and 2 to the third. So following this pattern, it's going to be x minus 2. Then we have a squared plus ab, so that's going to be 2 times x, and then plus b squared, and that's just going to be 4. Now, x squared plus 2x plus 4 can't be reduced anymore, so it's an irreducible quadratic factor. When that is the case, when you do the partial fraction decomposition, you're going to have one guy here that's x minus 2. You have this other one that is connected to this irreducible quadratic factor. Now, you might be saying, oh, I can factor that guy. You can't. You can't factor that guy over real numbers, so we're just kind of done with that. Now, the way the numerators go, the things we're going to have to find out works a little bit differently here. So this is still going to be a, but when it's an irreducible quadratic factor, like what we see here, we have to do both a variable term and a constant term. So we'll write bx plus c. So it's always going to be 1 degree less than what's in the denominator. All right, so now if we kind of go about putting in those missing factors, we would take a times x squared plus 2x plus 4 plus, now you gotta be careful here. This is going to be the whole quantity bx plus c times the factor that's missing for him, which is x minus 2. And this is supposed to equal the numerator, which is 4. So hopefully it doesn't look too bad here. We go through and we do the same kind of experiments, the same kind of examining that we did before. So a good value to plug in would be the critical value that happens when x is equal to positive 2. Because when x equals positive 2, that guy is gone. All right, so let's plug 2 in here for x, and let's see what we get. So this is going to be 4 plus 4 plus 4, so that's going to be 12. A equals, again, that middle guy is gone, and we just have 4 on the other side. So A is going to be 1/3. Okay, this is a very, very good start. Now, what would be another good value to plug in since we don't have another critical value? There's no other thing that's going to make it 0. X squared plus 2x plus 4, it's never going to equal 0. But you know what? We can get rid of the b by examining what happens when x is equal to 0. Now, it doesn't get rid of the c, but it means my b term is going to be gone. That's going to be gone. That's going to be gone. It still leaves me with a 4, but that's fine because I can work with that. That means I would have 4a plus, I plug in 0 here for x. That's going to be, actually, let me take that back. That's going to be, not plus, we're going to do minus 2c equals 4. All right, now we know what a is. So a is 1/3, so we have 4/3 minus 2c equals 4. Now, if you want to work with the fractions, you can. You can also clear the fractions out by multiplying times the LCD. So if I multiply both sides here times 3, not that this is a necessity, but it might help you out. 3 times 4 over 3 is just 4. Minus 6c is equal to 12. So we subtract the 4, we have 8, divide by negative 6, and you end up with negative 4/3. All right, I'll take that. So now we have 2 of the 3 unknowns. We have a and c, we just have to find b. So let's come back up here, and let's make a good choice for x. Something that's not going to be too rough for us. And for this problem, you might want to choose something like positive 1. That's an easy enough guy to plug in. Keeps things nice and small. So if I plug in 1, I get 1 plus 2 plus 4, so that's going to be 7a plus. Plug in the 1, this is going to be positive b plus c times I plug in 1 here. That's going to give me negative 1 equals 4. All right, so 7a minus b minus c equals 4. Let's plug in what we have. So it's going to be 7 thirds. Still have to figure out what b is. This is a minus c, but c is negative 4 thirds, so that's going to be plus 4 thirds, and that equals 4. Again, if you want to, you can go through and clear away the fractions by multiplying everything here times 3. You don't have to do that, but why work with fractions if you don't really have to, right? So 7 minus 3b plus 4 equals 12. Negative 3b plus 11 is equal to 12. So negative 3b equals 1, and b equals negative 1/3. So those are the values that we're going to be working with. All right, so we're going to rewrite our fraction using those guys. So our fraction is equal to 1/3 over the linear factor x minus 2. The other guy was over x squared plus 2x plus 4. And it was of the form bx plus c. So we'd write negative 1/3 x minus 4/3. So super fun, right? Let's see what happens if we were to do this next one. Oh no. It's even crazier, right? Well, yes and no. We have two quadratic factors that cannot be reduced. So it means we'll have two big fractions over here. One of them is over x squared plus x minus 3. The other one's over just x squared plus 2. However, because they are quadratic, what's in the numerator has to be part variable and part constant like this. So ax plus b. Now the other one, you can't still use a and b. You got to use something new. So we'll say cx plus d. All right, let's put in those missing factors. So we're missing, from this guy, we're missing x squared plus 2. And then we have cx plus d times x squared plus x minus 3. And all of this is equal to 2x to the third plus 4x squared plus 9x minus 17. Whew. That's a lot. Well, this is not going to be a lot of fun. Here's what we're going to do. You may not like this, but I didn't ask if you were going to like it. This is not going to be an easy one where we just pick off those critical values and we start plugging in numbers and we can get things developed very nicely. It's not going to work that way. You could see what happens if x were equal to 0, but you'd be left with both b and d, and that doesn't help us because we can't still get just b and d left from other ways. So we need to actually work this out, which means we got to go back to beginning and intermediate algebra where we FOIL, we multiply things. So we got to be very careful about how we do this. So we need to make sure that we take the a and distribute, take the b and distribute. So we end up with a x to the third plus 2ax. Now distribute the b. So plus bx squared plus 2b. Okay, hopefully that's okay right now, because we're going to do the same thing with this other one. We're going to take cx and distribute that guy. So when I distribute the cx, you know what? I'm actually going to color this one. So this is going to be plus cx to the third plus cx squared minus 3cx. And then we'll take d and distribute, so that's going to be plus dx squared plus dx minus 3d. And again, all of this equals 2x to the third plus 4x squared plus 9x minus 17. All right, from here, we are going to create our system of equations. So we have 4 unknowns. So we're going to have an equation that deals with just the constant, the x term, the x squared, and x to the third. So let's see what this looks like. Starting with the x to the third. So there's ax to the third, cx to the third, and then we have this. All right. So that means that if I were to take a plus c, that should equal 2, because those are the only pieces that are x to the third terms, so they're the only guys that would give me 2x to the third. All right, now we've got bx squared, cx squared, and dx squared, okay? And that should connect to my 4. So I'm going to say b plus c plus d equals 4. All right, that's for my x squared. Now we move on to our x's. So 2ax, no, minus 3cx plus dx, and that's going to give me 9. So let's see, that's going to be 2a, no b, minus 3c plus d equals positive 9. And then finally, we have plus 2b minus 3d. So those are the constant pieces that we have. So 2b minus 3d equals negative 17. So a system of 4 equations, 4 unknowns, and then we just need to go about solving this. Now, unfortunately, things are kind of messy with this one. We could definitely do this by hand. It would take some time to do that, but we can most certainly do that. Instead, I want to go over to my graphing calculator, and let's type this in a matrix. So let me go over and do a 4 by 5 matrix. So I have 1A, 0, 1, 0 equals 2. Then we have 1, 1, 1, and 4. 2, 0, negative 3, 1, and 9. Then we have 0, 2, 0, whoops, 0, negative 3, and negative 17. All right, so that contains all my information. So we're going to quit out of this. Under the matrix menu, we want to do the reduced row echelon form, so it just gives us our answers for matrix A. And this is what it tells me. It tells me that my A is going to be 2, B equals negative 1, C is 0, all right, and D equals 5. So when I write my partial fraction decomposition, we'll have 2x minus 1 over that first factor, x squared plus x minus 3, plus, now the other piece was over x squared plus 2, and it was supposed to be cx plus d, but it turned out that the coefficient for c is 0, or c itself is 0, and we just have 5. So that's what the partial fraction decomposition would look like. So sometimes we can make our work, it could be very easy for us. You let x be one of those critical values, or let it be 0 or 1 or whatever. This one, not so much so. So we go to a system to solve that. So we could definitely have solved it by hand, because we've talked about using the Gauss-Jordan elimination method, getting it to row echelon form or reduced row echelon form. But here, we got the calculator, so let's just go ahead and use that for now.